Hey everyone, welcome to lesson number 3. Today we're going to be looking at the cosine law. So if we look at this triangle ABC, in which angle A is 36 degrees, side AB is 3 centimeters, and side AC is 6 centimeters, we want to see what's going to happen if we set up the sine law to solve for length BC. So if we set up the sine law, 36, I have side A, I have side B, and I have side C. So setting up with the sine law, we're going to end up with A divided by sine 36 degrees, and we're going to have B, which is 6 over sine B, and we have 3 centimeters over sine C. Now, right now, if we take a look at this, if all things are equal, I have no way to link any of these ratios to one another. I'm missing 1 on each of them, which means that I cannot make a link between a side length and an angle for anything. So in this case, when we don't have 3 out of 4 pieces of information, we can't use the sine law. So this is where we got to use the cosine law. Now, this is an example that I think you can do yourself. And it's going to be using a process that is quite time consuming. So using this above triangle, what we do is we would make this into a 90-degree triangle, a right triangle. And what we would then need to do is we would have to use SOHCAHTOA to determine the lengths of side CD and of side length AD. So then we could subtract AD and AB in order to find BD. Even as I explain it, you can see that this method is going to be very time consuming. And because of that, we can use a different method known as the cosine law in order to solve this problem. So what is the cosine law, you may ask? Well, if I have a problem and I can't use the sine law, then every triangle we can use the cosine law. The cosine law is a squared is equal to b squared plus c squared minus 2bc times cosine a. Now, I'm also going to be skipping the proof of the cosine law, as I'm going to go through this briefly in class just to see how we arrive at this answer. And we're just going to jump into class example number 2, where we are going to be using the cosine law. Now, one thing that you want to know is that if you're looking at a triangle and you're trying to determine quickly whether or not you can use the sine law or the cosine law, with the cosine law, if your triangle is in this form, side, angle, side, where you have an angle sandwiched by 2 sides, then you can use the cosine law. So side, angle, side, you can use the cosine law. Now we're going to set this up for our cosine law here. And before I do so, I'm just going to be labeling my triangle A, B, and C. Now this is the triangle from the previous examples. And in order to use the cosine law, always start with the formula. A squared is equal to B squared plus C squared minus 2 times BC times cosine A. This isn't something you necessarily have to memorize. It will be given to you to reference on a formula sheet. However, what you'll probably find is you will just end up memorizing it, because with every question you should be writing it down like I've done here. Now we're trying to solve for length BC, which is side A in this case. And so what I'm going to now do is fill in my known variables. Side length B is 6 squared. Side length C is 3 squared minus 2 times 6 times 3 times cosine A, which is 36 degrees. Now, when I plug all of this in, you can plug this in stages if you'd like, or you can simply use brackets. Brackets are always a great idea. And I get an answer of 15.8753. That's a squared is 15.8753 with some decimals. However, that is a squared, and that is not a. So to the nearest tenth of a centimeter, we need to square root this, and we get 3.98. However, to the nearest tenth, we're going to round this up to 4.0 centimeters. So side length A is equal to 4 centimeters, or we could say side length BC is 4.0 centimeters. Now, another way we can set up the cosine law is if we have different variables. So for example, if I don't have an ABC triangle, instead of I have a PQR triangle, then my ratio might look a little bit different. So what we want to do here is complete the cosine law for calculating side Q. So if I'm looking for side Q, then we have to take the square of both of my other sides, and I need to find the sum of them. Oh, that should be a P, not a Q, sorry. This is a P, not a Q. And then I need to subtract 2, and then again the product of my opposite sides, R and P, and I'm going to be multiplying this by cosine of the opposite angle of this side length that we're looking for, cosine Q. So now that we have our formula, we can now determine what our missing side is, but we're going to take this information and we're going to fill it in. So side QP is equal to 1.7 centimeters, side QR is equal to 3.1 centimeters, and then we have PQR, which is equal to 110 centimeters. Or sorry, 110 degrees for my angle, not centimeters. Now, oh, and QR, I mislabeled this one here. Apologies. 3.1 centimeters there. Now, what we're looking for is we want to find the third side, which is PR here. And so PR is also Q squared. So I'm just going to write my formula again. Q squared is equal to R squared plus P squared minus 2 RP cosine Q. So I just took it from up there. And I like, even though it's up here, I like writing it every time. That way it helps me, it just reminds me of what I am filling in next. So R squared is 1.7 squared plus P is 3.1 squared minus 2 times 1.7 times 3.1 times cosine 110 degrees. All right, so make sure it's a great idea to get the practice here just so you know that you are inputting things properly. And you get an answer of 16.104. 16.104. However, that is Q squared and not Q. So we take the square root and we get 4 to the nearest tenth. 4.0 centimeters. Therefore, PR is equal to 4.0 centimeters. Lastly, let's look at this example here. I have Bellevue, which is 30 kilometers north of Ayer, and Churchville is 18 kilometers northwest of Ayer. Calculate the distance between Bellevue and Churchville to the nearest kilometer. So Bellevue is, so this is the thing where, this is where you might need to remember your unit circle and yeah, your directions. So it's Bellevue is 30 kilometers north of Ayer, and Churchville is 18 kilometers north of Ayer. So Bellevue, first of all, will go here, and Ayer will go down here, and we're going to say that this is a length of 30 kilometers. So here's Bellevue, and Ayer is down here. And Churchville is 18 kilometers northwest. So something like this. So we're going to say that this is 18 kilometers. And this is Churchville. And what we're looking for is the distance between Bellevue and Churchville. We're going to call that x. And if we're just saying it's northwest, then we're saying that this is 45 degrees. So we can now set up our triangle. We got C, A, and B here. And if we're solving for A, then we're going to use this A squared is equal to B squared plus C squared minus 2BC cosine A. And I will let you complete this question while I just go over one more example where we need to use the angle. Now, whenever we're looking for the angle for the cosine law, we can rearrange our equations to be from our regular form of cosine law to finding the angle of the cosine law. All we've done is we've rearranged and isolated cosine A. Now, when you're using this in practice, then what you're going to be doing is using the inverse cosine of this calculation that you performed. Now, this form can be used to determine any angle in a triangle when you are given the lengths of all three sides. So the code there is side, side, side. Now, if you're looking for angle B, the form of the cosine law you're using is going to change. So rather than being cosine A, B squared plus C squared minus A squared divided by 2BC, it's going to be C squared plus A squared minus B squared divided by 2CA. So whatever angle you're finding is the side length you're subtracting. So if we're looking for cosine C, this is going to be B squared plus A squared minus C squared divided by 2BC. Sorry, this is not correct. This should be B plus A minus C divided by BA. Now we want to determine the largest angle in ABC if side length A is 14.7, B is 8.9, and C is 12.6. So let's draw our triangle. So side length A is 14.7, side length B is 8.9, so this should be smallest, and side length C is 12.6. And we want to find the largest angle here. So first, let's just kind of label this. If this is side length A, this is angle A. If this is side length B, then this is angle B, and then this will be angle C. So if I'm solving for cosine A, we're going to use B squared plus C squared minus A squared divided by 2BC. And we're going to be using the inverse cosine here. However, I'm just going to plug everything I have in, all the information I have. So this is 8.9 squared plus 12.6 squared minus 14.7 squared. And we're going to divide this by 2BC, so 8.9 times 12.6. So when I plug all this in, I have 8.9 squared plus 12.6 squared minus 14.7 squared. And I'm just going to start a second line and divide this by 2 times 8.9 times 12.6. And I get cosine A is equal to 0.0975 ... And this is where we need to use the inverse cosine. And the angle we're given here is going to be 84 degrees.